Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep. Math and physics while them haters count sheep. Actual education, tune in and get schooled. Flipping textbooks, breaking all the rules. From Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Gracing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Happy Monday fun day.
My man.
A little bit of an earlier stream today. I have to do a bunch of meetings this afternoon with my work stuff before I go to Japan tomorrow. So we're sneaking in one more office hours before I'm gone for the next 2 weeks. So welcome, everyone. Nice, Crazy. You found a way to decompose it? That's cool, dude.
That's dope.
What's up, below? Good to see you. Nice. All right, great. And we're running there. Sweet. News, let's see. Besides this being the last stream for like the next 2 weeks, we do have some fun events coming up from our other friends and streamers, especially with Pi Day coming up on Saturday.
That's dope.
So, again, if you go to our website, actualofficehours.com, you can click on the streaming schedule here, and there's a lot of really fun streams going on. So, Pi Day, that's going to be a really cool one.
Good job.
3:14, starting kind of in the morning, I guess. So you got to wake up a little bit early for it. But we're going to make an announcement here. There's going to be a really fun trivia game that I'll be hosting from Japan. So international. What's up, Gladiator? News has 104.6 thousand channel points.
Oh, yeah.
Wow. I need to come up with some like really, really cool redemption for that. Yeah. They have like group channel point things you can do as well. Super cool. Go see Gladiator. All right. So yeah, that's it.
We won't be streaming here for the rest of this week, the rest of next week, but we will return on the 22nd probably. So yeah, come on out, have fun. Points well spent. The baby voice. Love baby voice. Are you going to Japan for business or fun? It's mainly fun. I still have to like do some work stuff, but no, I'm not going specifically to Japan for work. I'm going to Japan because my work allows me to go to Japan.
Because it's remote. I can work from wherever. And it's one of my like big themes with life and advice I would give to you guys when you get old enough, when you're like at least 18 or 21. Go travel as much as you can. Because there are very few times later in life that you can do that without like having too many responsibilities.
Disqualified.
Anyways, okay, cool. All right, so that's it for news. I'll still be around in the Discord. Just, be nice. keep things from burning down while I'm out. And then when I get back, we'll have a lot of really fun things going on. We had a great weekend. We did a chess tournament on Sunday. That was dope. We did the podcast on Friday. We did recess games. Oh, sorry, the podcast was on Saturday. Recess games on Friday. And now we're streaming homework help again. So, I've never watched your streams, but I have a question. What's your question, Fort Gonzox? What's up, dude? What's your question? If you have a math or science question you want to submit, the website, actualofficehours.com, this is where you can upload a screenshot of something you want us to go over live on the stream, and then it'll get added to the queue here. Oh, 1K, you submitted something 144 minutes ago? Huh? Technically, you're not allowed to do this, but I think I'll keep it just for now. It's okay, 1K. I'm sure you have an answer. Right. Okay. That being said, here, let's start off the stream. Help you guys out. All right, welcome to Actual Education Office Hours. My name is Dr. Gold. This is a stream that helps you with math and science homework.
Perfect. Nice.
All sorts of fun math and science stuff going on today. Let's see what's in the queue for the questions today. Looks like we got 2 submissions so far. Let's go choose a winner and see who we're going to work with.
Let's go gambling.
Pretty sure 1K is going to get picked. He had a 90% chance. Okay, let's see what 1K's question is. Ooh, this is like the lowest resolution thing I've ever seen, dude. What? No. What's up, Andrew? What'd you finally get to work? Chat? Did you finally get chat to work? Ooh, yeah, Fort Gonzox, don't paste like questions in chat because they're gonna get lost in chat. If you want to take a screenshot of that question and then upload it to the website, that's the best way for me to answer it from you. Yeah, where you submit the questions. Okay, if you hit !submit, it should show them for you. That'll tell you. If Nightbot wants to say things. The soundboard. What's up, Bella? Yes. Okay. Yeah, that's the website there. Fort Gonzox. Just, yeah, dump them in that. Yeah, and Apara's, yeah, Twitch schedule is usually right, but not when we have changes. I'm looking for some advice. Would I still type in the submission place or for questions? You can try typing in chat. I might get to it. If it's something a little bit more elaborate, try taking a screenshot of whatever the text is and just upload it. A screenshot would be better. Yes. Yeah. Okay. Here. Let me do this question for 1K. A concrete contractor is creating 2 rectangular slabs. The first slab has a width and length that are the same lengths, and a height that is 1 meter greater than its width. The second slab is made by doubling the height, increasing the width, and increasing the length. The volume of the second slab is 216 meters cubed greater than the first. What are the dimensions of the original slab? This is fucking word salad. There's so many words in this question. Okay, but anyways, we can still do it. All right. So let's come up with some variables. Let's say like slab 1. Whenever you get word salad questions like this in math, just go sentence by sentence and try to identify like what each word corresponds to into like an equation. Okay, so the first slab, and let's talk about the volume. Let's call it like V1. V1 would be equal to L1 W1 H1. Okay, but something we know here is that the width and the length are the same lengths. Okay, so now I can replace this with also just length 1. And a height that is 1 meter greater than its width. Okay, so this is another cool thing. So the height, so actually here, let's write down what we know, right? We know that width 1 is equal to length 1. And we also know that height 1 is equal to the width plus 1. What's up, Charlie? Yeah, so if I want to plug all of these things, right, and then also W equals L, right, so it's the same thing as L1. I can then plug all of these things in for here, And so we're going to get that V1 is equal to L1, L1, L1 plus 1. Love it. Okay, great. Second slab. So second slab would be V2 is equal to L2, W2, H2. We double the height. Okay, so the second slab is made by doubling the height. Okay, so H2 is equal to twice H1. The width is increased by a meter. So we say width 2 is equal to W1 plus 1. And then, thank you, Charlie, for sharing the live stream. I didn't know you could spam shares like that. Man, TikTok, we gotta chill on you, dude. Sorry, Charlie, I gotta block you. Okay, and then what do we know about also the height? Or no, wait, we got the height and the width. What do we know about the length? One second, let me clear this. There we go. And increasing the length by 2 meters. Oh, okay, so length 2 is equal to length 1 plus 2. Got you, okay. So those are the things we know. And then the volume of the second slab is 216 meters cubed greater than the first. Okay, so here we go. Let's write out some equations here. So V2 would be equal to, let's see, 2H1. Okay, cool. Yeah, physics. I like, yeah. Nice, good job, Andrew. Okay. So that's equal to 2H1, W1 plus 1, and then L1 plus 2. But now I think we want to use the stuff about this to try to like make this into just... See how everything here is just in terms of L1? I want things here to also just be in terms of L1. So let's remember, right? H1 is equal to L1 plus 1. So this is the same thing as 2 times L1 plus 1, right? And then we also know that W1 was equal to L1. So now I can replace this as L1 plus 1. And then, let's see. Oh, and then we still have just L1 plus 2. Great. Awesome. I actually like that. That's really good. Beautiful.
Good job.
Okay. This is V2. And we also know that V2 is 216 greater than the first. So V2 is equal to V1 plus 216. That's the other bit of information they gave us. All right. All right. So now we have a lot of equations. But I think we can solve for things. All right. We're going to take all of this. We're going to plug it in there. We're going to take all of this. And we're going to plug it in there. And let's see what we get. So there's a lot of hot garbage here.
Bullshit, not good.
Oh, man. Okay, so wait. 2 L1 plus 1 squared. L1 plus 1 squared. L1 plus 2 is equal to V1, which is L1 squared. L1 plus 1. And then plus 216. Great. Okay. So yeah. This came from all that. This came from all that. It's a cubic, but the cubic term drops out. I don't know that it drops out. I got a 2 on this one. Do you smoke cigarettes? No, not really. Do I sound like I smoke cigarettes? You know, we got that like raspy voice. This is just a mess.
Huh?
Right? Yeah. This is just annoying at this point. I'm not gonna waste time doing algebraic manipulation. So I'm just gonna use ChatGPT for this. So expand to L plus 1 squared L plus 1. It'd be nice if at least like something like canceled or something, but it doesn't. Or it's L1 plus 2. Fuck. No. Stop. Chat, you need to stop. There you go. There you go. It's just a mess. Just give it the whole problem, have it do it. No, I at least want to show like the steps, so it's not terrible. There you go. But this is what I wanted. Yeah, okay. Cool. Alright, so this is in expanded form. That's what I wanted. I trust you know how to expand things. What's up, 1K? We're doing your question. Okay, so that turns into that. And then I want... This one's actually not bad, right? Because then this is equal to... This is L1 squared, so that becomes L1 to the third. And then plus L1 plus 216. Nice, okay. So now you can start combining some terms and stuff. So if you move that over, you end up getting... so L1 to the third plus 8L squared plus 9L minus 212 is equal to 0. Every time I get... Oh, the Team Rockets leader? Yeah. Giovanni or something. Team Rockets leader. I assume L equals 11. Is that how this works? If you plug that in, do you really get L equals 11? Okay. If you solve this... L1. Oh, L equals L1. Yeah, my bad. Sorry, yeah, technically I should write that. What do they want by the end? Sorry, what do they want? What are the dimensions of the original slab? Okay, great. Yeah, so we just need L1 basically at this point. Do we want to do the rational root theorem for 212?
Surprise, motherfucker. Stop, Aaron!
It's so messy. Okay. I'm gonna have it just factor it. You would have to like plug in things to try to make this work. So we're gonna say L to the 3. Isn't this your question, 1K? This is the one you submitted, no? The one with the slab of the slab of the concrete. Spectroscopic notation? Yeah, I don't want to really do factors of 212. It's like, is 11 in there? I'm trying to think. Definitely got 2 and 4 and 50. No, 4 and 53. Right? That's all you really got. Yeah, 453. Yeah. So these are the possible factors for the rational root theorem. I don't want to test these though.
You're not that guy, pal. Trust me. You're not that guy.
All right. I guess it's probably the 4. Yeah, just ask chat. I think 4 works though. Yeah, we can actually kind of do it by inspection because look how all of this has to add up to 212, right? So if it's 1, it's not going to work, right? Because 1 plus 8 plus 9, not going to work. If it was a 2, that's 8 plus 32 plus 18. That's not going to work. So I think 4 works. Pretty sure 4 works. Yeah, I think this would... I don't think 53 is going to work, right? Because 53 cubed is way too big. Yeah. So you can test it. So 4 cubed plus 8 times 4 squared plus 9 times 4. That's 64 plus... what was that? 128 plus 36. Oh, that's not good. 16 times 8. Does that equal 212? It doesn't. Right? Yeah. Oh, so there aren't any really nice factors of this then, are there? Unless they're negative, Oh, there could be negative ones though. Oh, and you know what? There probably do need to be negative ones because I need it to become like x minus something, right? In order for me to figure out like what the root is. Yeah. Yeah, let's just have chat do this. Here. Factor this. What's up, Iverson? Yeah, synthetic division would work. It's just, I think it's one of the negative factors. Yeah, so 4 doesn't work. Wait, negative 4 doesn't work. It doesn't have any simple factors. No. There's only one real root, which is 3.75. Dude, how are we gonna get that? Okay, so factoring doesn't work. Yeah, you'd have to graph this. But let's say if you graph L equals 3.75 does. I mean, here, I could show you how do you do that. At the end of the day, yeah, I mean, it would have been nice if this question had some good factoring that could have been done. Well, you wouldn't even have gotten it. You can't. The rational root theorem just says that, like, it's possible that those roots could happen. They don't have to. So what you'd have to do is you have to do this. You say, like, x to the... You'd have to go to... Sorry, let's go. Get out of here. You could use Cardano. Yeah, that's another one, but I don't think a high school student needs to use Cardano's formula. 8x squared plus 9x, right, minus 212. And then what you do is you just trace this. And I guarantee it's going to hit somewhere. There it is. So then you just do second calc. Well, sorry, not intersect. Calculate the 0. No, wait. Second calc. But, come on, calculator. Second calc 0. There you go. Yes. It's actually not 3.75 either. It's 3.86. So actually, I think chat got this wrong. Yeah, let's see if we did this, right? Yeah, minus 212. You dumb messed up, G-hold. Yeah, no. It's not 3.75. Yeah, L equals 3.86, I think. Okay. And then so from before, right? L1 also equals W1. So W1 equals 3.86. And then the height, I think, was 1 more than it, right? Yeah. The equation is supposed to be L cubed plus 7W squared. I don't see that. Yeah, maybe I made a math error. Okay, fine. Let's go check. That's why this is kind of like a poorly designed question, because if you make like one simple arithmetic error at the beginning, it turns this into just a mess. No, it's okay. I can see it. Just give me a second. Chat will get it. We got the 10W. The difference is here. Well, wait. No. Because I got 9W. One sec. It's gonna go through. X squared x plus 1. Yeah, that's what we got. X squared x plus 1. Cool. And then the other one was 2x plus 1 squared x plus 2. Yeah, that's what I got here. Yeah, no, I think I'm pretty close. Okay. Unless Gemini might have fucked up, honestly. So they got 2x cubed plus 8x squared plus 10x plus 4. That's great. I know that. Yeah, cool. Where's my last thing that's wrong then? And then this is... I see where this is wrong. This should have made this L1 squared. Aha. Okay, fine. So yes, that would make this 7. Cool. And then this is 10L. Okay, that's just... It's still ugly. It's still, like, not nice. It doesn't matter. So... Yeah. X equals 3.965. Here, we can show that in the calculator real quick. Yeah, it's still not nice. I mean, you could do it in 30 minutes. It's just, it's just, I don't know if this really, like, teaches math. Just teaches you how to, like, brute force something. I mean, the setup's at least kind of mathy. I agree with that. That's kind of cool. All right, here we go. 0. No, come on. There you go, 3.9. Yep, there you go. That's what chat got. Well, you can't do this without graphing. I'll tell you straight up. I don't know how you would use any sort of formula to solve this without graphing. You could use the binary method. I don't even know what that is. Okay, there you go. All right, L1 equals 3.96. H1, or sorry, W1. No, W1 is equal to 3.96 as well. And then H1 is equal to 1 plus that. So 4.96. Yeah, there we go. Cool. Alright, yeah. That's how you would do that one. Kinda sucks, but fuck it.
That's dope.
Yeah, I don't think that's what they're looking for either.
Well done. Well done.
Yeah. I don't know how you're supposed to do that without a graphing calculator. In high school, no. No. There's no way to do that. And using high school methods, I don't think so. Okay, cool. Good job, 1K. The setup was cool. A little bit of the algebra was cool. It's just, that's poor question design because the resulting cubic we had to solve wasn't factorable. If you're making good questions that could be solved without a calculator, they should have made this last cubic something that was factorable. It's not.
You done messed up, AA Ron.
Unfortunate. Okay, cool. All right. But here, let's go. Let's see what we got for other questions. Nice. Okay, cool. Great. Let's go pick one.
Let's go gambling.
Parzi, it's you, dude. Nice. Okay, what's up, Parzi? This is literally your question. It's okay. I'm glad you put it as a screenshot because now I will actually answer it. All right, here we go. Here we go. I'm in geometry right now. I was wondering if you had any advice on what would be the best thing to do to get a 5 on the geometry EOC. What is geometry EOC, by the way, first off? Oh, end of course is a mandatory high-stakes exam for students in geometry, often accounting for 30% of the final course grade. Oh, okay. I guess it's a Florida thing. That's fun. Wow, this is funny. They give a little diagram of like what the graphing calculator is. Like how to use it. All right, cool. What's any advice on what would be the best thing to do to get a 5? Practice. I mean, there's no substitute. There's no shortcut for like just doing the work, honestly, with any of this stuff. So, yeah, you want to do well in an exam, take a lot of practice exams and see where you're getting stuff wrong. I will say something that's really cool that I kind of just noticed. GPT pen.
Surprise, motherfucker.
No. So actually, there is this. I've been using this with some other stuff. I'm going to show it to you guys. It's actually really cool. It's called Notebook LM. You guys ever heard of Notebook LM? It's Google's new kind of studying resource, which I think it's really cool actually. You may need a paid plan for this, but I'll just kind of show an example of how it works. You can create an environment and just drop. This is actually what I've always thought of doing for students, but blessed Google is billions of more dollars and they just did it first. But if you drop in all the files related to something that you need to learn, it will only search those things to create practice quizzes and podcasts and stuff. Yeah, it's super cool. So for instance, this is an example sample question, right? So you could download this. Be like, here, I'm gonna get this thing. This thing's cool. And then I'm gonna drop it into Notebook LM. Oli says, for geometry, I suggest you imagine figures and diagrams in your sleep. Okay, here we go. Okay, we're gonna drop some files in. So that's something that was related, right? Here's some more sample test materials. Look at all this. They have all these sample tests, right? Here, we can download this one as well. There. Let's drop I think you go here and just add more resources. Where's add resources? Add sources, there you go. What's up, Monkey Man? There you go. There's another one. Here's another EOC practice test. This is for 2014 or something. Wow, this is kind of old. But there you go. There's another one. Where did I put it? There it is. Actually, I don't think we want this one. Sorry, this is a different test. We don't want this one. There we go. Yeah. So anyways, you put this in, right? And what you can do is you can create, let's just create all these things. They say let's create a mind map, okay? So mind map is what stuff you should be learning. You can create flashcards. You can create a quiz. You could create do a podcast. I don't think you really need a podcast for this. I do use the podcast feature a lot for if I'm given pretty complicated business plans or long documents that whatever I need to analyze for partnerships and whatever other fucking bullshit. It is great to have this create a 20-minute podcast so that I can just listen while I go for a run or I'm stuck in traffic. Super cool. But here, for instance, this created. Look at all this. This is super cool, actually. Pythagorean theorem. Dude, it creates all these. You can learn about individual topics here. Yeah, look at all this stuff. It just starts writing things. Wow. And you can generate flashcards. Yeah, right? So, let's go back to the... How do I go back to... I want to, like, close this, though. Oh, yeah, there we go. Did we do the flashcards yet? Let me see. Flashcards? No, that's the blueprint. Where's the flashcards? Oh, it's still generating the flashcards. Oh, no, here it is. Geometry flashcards. Let's see. Where are my flashcards, though? What? Yeah, podcast. Yeah, for analyzing articles, 100%. Yeah. I wish I had this in grad school, man. If I could just dump, scientific articles and just, like, listen to podcasts about them while I'm, like, doing other things, like doing the dishes. It'd be super cool. They made a quiz. Here we go. So this is cool. So here, it creates, like, this is a 10-question quiz. And it even has, like, hints that you can use as well. Look how dope this is. This is super cool. Yeah. So here, if you want, what I'll do is I'll share this with you. And that'll allow you to use, I guess, whatever my advanced AI subscription was. So you can actually just, like, here we go. I'm going to say, like, anyone with a link can view, can chat, view sources. Yeah, here you go. Great. And let me just copy the link for you. Did it copy? Hope it did. Yeah, it did. Okay, cool. So, nice. Cool. Good question. I'll show you what I'm going to do. So, in our Discord here, your question will get brought up in the homework help thing here, Andrew, of Pars. And so, what I'm going to do here is I'm going to drop in the Notebook LM link for that, if you want to just take a look at it. There's some cool stuff in there, probably. But in general, if you want to get better at standardized tests or math competitions and doing things like that, the best way is to do practice tests. So, Google's your friend. You can use that to find previous year's tests, and then you can also use this AI platform that Google has developed to then generate even more, like, quizzes based on that material. Super cool. You guys live in, like, a wild timeline. I mean, it's pretty fucked in some ways, but also really cool in terms of all the innovations they have now for learning. Yeah. So, anyways, cool. Just sharing some stuff I've seen. All right, let's see. We got another 3 questions on the queue. Let's go choose a winner.
Let's go gambling!
Crazy Run Fam!
That's
Alright, let's see what you got. Integral of the square root of secant tan of x. Okay. Alright. I always kind of, like, dread
That's dope.
the integrals you give me. Because I know this is going to be a mess. They're never anything nice. Okay. Integral of secant x tan of x dx. Well, I know ddx of secant of x is equal to secant of x tangent of x. Okay. I could also write this another way. Yeah. Okay, Gladiator, it's okay. We'll see. I mean, this one maybe is not bad. If not, don't worry. Every time we do a question, the link for it gets posted. But yeah, let's think about this also, right? Okay, so secant of x is equal to 1 over cosine of x. Tangent of x is equal to sine of x over cosine of x. So secant tan is sine over cosine squared of x, whatever. Okay, cool. So, this is also the integral of the square root of sine of x over cosine squared x dx, which, yeah, Jeff recognized. Oh, well, this is pretty cool, because now this is sine of x to the 1/2 over cosine of x dx. And I think here's where I'm going to do a u sub, maybe. Yeah, u is equal to sine x. And then, but here's the issue here. du is equal to cosine x dx. Yeah, yeah.
You done messed up, Aaron!
Yeah, the issue is that I'm going to get another cosine down on the bottom. It's not going to really help me here, right? Yeah. Fuck. No good. Yeah, it's a wolf in sheep's clothing. What if we multiply the top and bottom both by sine? What if we do this? I don't know. Let's just do sine of x over sine of x. I don't know. Maybe this works. And then if u is equal to... Oh, you want u to be this? Yeah, okay, we can do that too. Let's try that. All right, I'm down. I'm down. We'll say u is equal to sine of x to the 1/2 dx. So then du is 1/2. But look, this is sine of x to the 3/2. Or sorry, u is equal to sine. Okay, so there's 1/2. Oh, to the negative 1/2 is what I meant to say. And then it's cosine x dx. Yeah, that still doesn't help me though, right? I'm still gonna get a cosine squared x on the bottom. What's up, Amir? Well, u to u is kind of it, yeah. Yeah, but cosine of x is on the bottom is the issue. Right? When I rearrange this for dx, the issue is I'm just get more cosines on the bottom. I don't really like that. Fuck. Yeah. You learned the circle equation. Nice, dude. Yeah, equation of circle is great. Well, okay. Well, also crazy. Where did you get these integrals from? Are you just like coming up with things in your head? Because not everything in your head is actually solvable, like nicely. I mean, it's cool that you're interested in this, but it's kind of a time waster if there's not actually a solution for it. Yeah, well, this is getting bad already. A logarithmic derivative. It's elementary? I don't think it's elementary. I'll tell you right now. No. It's not. It's not elementary. Wow, okay. Yeah, you just have to like kind of guess that u is the square root of secant plus tan. It's trivial, really? It's the worst. I hate when that shit happens, dude. No. My quantum mechanics teacher in undergrad used to say things were trivial, and I was like, get the fuck out of here, dude. It's not trivial. Yeah, I'm gonna pass on this crazy run because it's just not really solvable. Yeah. It's a bunch of like guesswork and picking out clever things that happen that you'll never do ever. Yeah. It's okay.
Yeah.
I'll give you the chat solution if you want to go through it, but you don't really learn anything from that. It's not really useful. I challenge you, if you want to see like integrals that teach you things, you should go to this like integral of the day or something Instagram. Yeah, integral every day. Is this it? Integral every day? Is this the account? Yeah, because these also at least have the solutions, which then you can look at, and maybe these are pretty clever. Yeah. Or yeah, stuff like this. Yeah, try these. Try doing these at least. I feel like these are a better use of your time than attempting like obscure integrals that don't really have. They don't have nice solutions, or the solutions they have are just lucky guesses. And lucky guesses isn't really a way to go about life. Yeah, integral of the day is cool because I think they at least pick ones that teach you certain techniques. Like this is a cool one. Yeah, you're trying to. It's like clever U sub. This is clever U sub. That isn't like too terrible. Or like I guess you could maybe do partial fractions with that one. Yeah. Well, anyways, go check the link I posted. Let me go help out some else. All right, let's go see who we got. Let's spin the wheel. What's up, Haunted? All right, here. We'll see if we get picked.
Let's go gambling!
Gladiator, you should get picked. You have the biggest percentage right now. And you are. Nice, Gladiator. Okay, here we go. Ooh, energy level diagrams. These are fun. Okay. What's up, Tubo? Energy level. Now, what type of energy levels are we thinking about? Not chemistry. Where's JC, dude? So when I think about energy level diagrams, I want to know. Oh, they're calling it. Oh, this is an energy level diagram. Okay. I was thinking of what's the other one where it's like you have them. I think it's like hybridization energy diagram. They're not working on Google. Try refreshing. Use incognito mode, Tuma. I think you may have the old yeah, the one with the arrows in the boxes. Yeah. The other one is this. These ones are very cool. Hybridized orbital diagrams. These are really fun. I've done these before. Yeah, these are also really cool ones. Also, Tuma, try doing it on your phone. I'm curious. Let's get a blank one. Yeah. Here we go. This is kind of cool. I like this. I just want like kind of a better resolution. Okay. So they want one for phosphorus. So P. So you gotta go look at like where P is on the periodic table. Opera GX search. What? Tuma, what? What are you even talking about, dog? What? What do you mean they're not working on Google? Okay, first of all, I think you're getting your names mixed up. You mean it's not working on Chrome? Oh, man. Okay, there you go. It's not working on Google.
Surprise, motherfucker.
What? It's not Google. It's called Chrome. All right. Phosphorus, Google Chrome. There we go. Better. Yeah. Better. Yes. 15 protons. So when it's neutral, it has 15 electrons. Let me just get a picture of this. So nice. Yeah, phosphorus is right here. Okay. So that would be 1s2. So you can actually just write them out first, right? So that's 1s2, right? I think you guys do it like, right? Yeah, 1s2 for here. Then you have 2s2. Then you have 2p6. And then you have 3s2. Or actually, wait, 1s2, 2s2, 3s2, and then here it's going to be 3p1, 3p2, 3p3. There you go. So yeah, that's like the electron configuration. And so then you just fill them in. So this would be up, down, and then we go to 2s2. So up, down. I was not made for chemistry. Chemistry is great. I love chemistry.
That's dope.
Chemistry is really fun. It's like kind of my other favorite thing to teach. All right, up, down, up, down. 2p6, so that's up, down, up, down. Actually, I actually have arrows, actually. Wait, one second. Let me just use the arrows. Yeah. Up, down. Up, down. Up, down. Up, down. Up, down. Up, down. Okay, and then you have to use what's called Hund's rule whenever you start filling partial ones, okay? So it's 3p3. Some students are tempted to do this.
Surprise, motherfucker.
Well, that's wrong. Hund's rule says that we have to do them all up first, and then any additional ones would then do this. But it's only 3p3, so you just leave it like that. Yeah. So here, this was phosphorus. Nitrogen just stops at 2p3. You can see it's in the same column too, right? So nitrogen is 7 electrons. And so that's just 1s2, 2s2, 2p3. So it looks kind of the same. So up, down, up, down, up, up, up. And then there's a cadmium ion. Oh, interesting. Wait a minute, sorry. Ion. But what ion is it? Is it like +1, +2, +3? Like what? You don't really know, right? So nitride ion, is that gonna be N3 minus? Right? That'd be 1 minus, 2 minus, 3 minus. Is that what a nitride ion is? Nitride ion 3 minus? Let me see, like, electron configuration for nitride ion. What does it mean by ion? Uh-huh. Okay, yeah, so they do mean it's when the atom forms its stable octet. Wow, that's cool. Okay. So yeah, so this one is technically N3 minus because nitrogen would be here. So it means its outermost valence shell would be like 2s2, 2p3, but ions want to have full valence shells, so it needs to add another 1, 2, 3 electrons to become 2p6, and that's why it becomes N3 minus, because it's nitrogen with an additional 3 electrons on it. Ah. Okay. So this is N3 minus. So now you get these filling. Okay. And then it's gonna be the same thing kind of for cadmium. So cadmium is, where's cadmium? CD. Right here. Okay. Nice. Yeah, self-studying is dope, dude. Maybe go take some AI courses or stuff. It's kind of all the future. Cadmium's weird. Okay. I'm going to do this in what's called like noble gas notation. So noble gas notations means you go down the noble gas column and you figure out which one is right above the row that the thing is in. So because cadmium's in this row, we're going to say that this is krypton. So CD is equal to, and you put like a bracket around this, and you say, oh, it's equal to krypton plus. So this would be krypton plus, what is this? 1, 2, 3, 4, 5. Okay. Plus 5s2. And then we got to go across here. So these ones, the D blocks, are always one less than what the S blocks were. This is like, this is 4S, but then this is 3D. So this is 5S. This is 4D. So cadmium is going to be 4D10. Okay. 4D10. Wow. Is that full, though, for the... Let me see what a cadmium ion would be. Let me see cadmium ion. I wonder if you need the extra 6 electrons. Yeah, no, they just leave it at 4D10. Yeah. And they call it... Oh, they call it cadmium 2+. Oh, fascinating. Oh, okay. Here. Okay. But the ion is a full valence shell. This is actually really cool. So cadmium 2+ is just equal to krypton 4D10. The reason for this, right? Okay. Cadmium technically has 2 electrons in the 5s valence shell, and it's easier for it to lose these 2 and then only have things in the n=4 layer than for it to go ahead and gain another 6 electrons from the 5p6 shell. So this is cool. So actually, yeah, so when you talk about ions, right, this is +1. This is called like ionic number. +1, +2, +3. This is like ±4, -3, -2, -1. The reason being is for something to have a valence shell that's full, let's say if it was here, fluorine has 7 in its valence shell, so it becomes a -1 because it adds 1 more electron to fill out the full 8. Beryllium, however, becomes Be2+, because in order for it to have a valence shell that's full, it would rather lose these 2 electrons and then have this just be the full shell. Kind of the same thing, I guess, with aluminum, right? Aluminum is a 3+ in its ion form, because rather than gain another 5 electrons here to become like Al5-, it's easier for it to lose this, lose this, and then now its full shell is the n=2 shell. And that's why it's Al3+, because it's 3 positive charges or 3 missing electrons compared to regular aluminum. So this is why cadmium is 2+, because it wants to get rid of this. It wants to get rid of this 5s2 rather than build out the next 5p6. Very cool. Okay. So, yeah, if you had to draw this, just fill everything. This is kind of annoying. But there you go. 3D. Oh, man, so much. Okay, 4p. And then we don't fill the 5s.
Disqualified.
But we do fill the 4D10. Okay. I think that's it. I think this is cadmium 2+. Go check with your teacher. But that should be it. Cool. I haven't seen stuff like that in a while, honestly. Okay. Yeah, no, 5s is not filled. Yeah. Because, Zach, valence electron doesn't go in terms of strictly energy level. It goes in terms of n=1, n=2, n=3, n=4, n=5. So, what you end up saying is that in order to fill the 4 out, to fill n equals 4, I'd rather lose the 2 from 5s2 than try to build out another like 5p6. I think. Again, I would defer to JC. JC probably knows best. Well, it makes most sense to me. Also, I mean, we see some websites here, right? Does this have the ionic? Yeah, that's the electron configuration. I don't think they're strictly in, no, I don't, well, see, let's see. If we say, like, valence electrons in cadmium, I think it'll say 2. Yeah. So cadmium has 2 valence electrons. So even though, for instance, 4D is technically at a higher energy level than 5s2, it's the outermost. Yeah, it's not by energy level. It's by n number. Because AI said so. I don't know. I mean, a lot of the websites seem to believe in it, I guess. This says 2. The internet says 2. I know valence electron goes by n number, not energy number. It is cited somewhere though. Yeah. Again, this whole like area here is kind of a no man's land in terms of like what ionic charge is. This is always like maybe +2, maybe +3. It has to do with some weird stuff, I remember. Like, okay, so for instance, like copper, right? Copper, I believe, is 2+, because yes, it would lose these 2. But sometimes it makes it full, like it makes it more stable if it like pulls it from these. Yeah. Wait, these are what are these called again? These aren't the transition metals, are they? Yeah. Okay, here we go. Yeah, let's see, like ionic of transition metals. Yeah. Yeah. Yeah, they're weird, right? It's either like +1, +2, +3 or something. But it's here, chemistry Libre text. This is pretty much not AI, right? This is a textbook. What's up? IIT Tianjin. Cool. Yeah. Okay. Cool. All right. Let me move on to the next question though. I should get JC. JC should start streaming again. Where's JC? JC would stream. We could ask him about these things. We're doing some questions. Let's see what we got. All right. Let's go choose a winner for the next one.
Let's go gambling!
Kind of even here. Haunted! What do you got for me, Haunted? Ooh. This looks like some set theory thing for Zach. Why does chromium have more than boiling point's 3D elements? Equivalence relation? Here is the question to my solution. Oh, okay. Okay, it says, given that, prove that if, I don't know what this means. Okay, if AB is equal to A union B, then given any XY in the set A and any set in the CD, any CD in set B, we have XY is equivalent to CD. Okay, A union B means that A is in A union B, B is in A union B, since XY is... Wait, what does this mean, Zach? Zach, what does this mean? What is this? I don't know this notation. I know this is like is an element of, right? Yeah. Oh, is a subset. Okay. Okay, is an element. This is a subset. Cool. Ooh, wow, you got the fancy ASCII. That's cool. Okay. Superset. Ooh, that's superset. Okay. Okay. And then I believe this is an operation of A and B. Is A and B are like operating on each other in some manner? I did this a very long time, not a very long time ago, but a couple weeks ago with you guys. Like, what is this? I feel like this is like A and B do something to each other, or in a function. Oh, it's an ordered pair. Okay. Yeah, and then what do the brackets around it mean, though, right? Oh, okay, I get it. The bracket is saying... This is the notation for saying that A union B equals A union B? Nice, yeah, signal analysis is good. You should do Laplace transforms, Big Monkey Man. If you want to, yeah. Go check out Zach's streams. He does a lot with... like differential equations and Laplace transforms. Here, let me give a shout out to Zach. If you're not following Zach already, you really should be. He's cool. And he knows more high level math than I do. Okay. All right. What do the brackets mean, by the way? What do the brackets mean? Or is that just like the notation for A union B? Equivalence class. Okay. Okay. Given any XY that is an element of A and CD is an element of B, we have that XY is equivalent to CD. Given, okay, A is a subset of AUB, B is a subset of AUB, and since XY is an element of A and CD is an element of B, and given this implies that XY is an element of AB. Okay, so you know 13 is really 1 p.m. 13 is the equivalence class of 1 with respect to a 12-hour clock. 16 is equal to 4. 21 is equal to 9. Oh, okay, yeah, in terms of hours. Okay. I think I get that. Yeah. Like, it means the same thing. It's just written a different way. Kind of like, sure, like, I don't know, like, 21 mod 10 is the same thing as 1. Is it just, like, 2 different ways to write it? Okay, so if AB is an equivalent class of A union B, so that means, for instance, if this is A and this is B, like let's say these are two sets, right? The overlap right here, right? Is this A union B? Is that what we say? Zach says some context is missing in this class, in this question. And okay, so if XY is a exists as an element of set A, and CD is an element of B, we have XY is equivalent to CD. Oh, okay. Oh, man. Okay. Equivalence class of AB means that there's an XY, which is an element of Q, such that XY is equivalent to AB. Also that CD is an element of Q, such that CD is equivalent to AB. So XY equals AB, CD is equal to AB. CD is equal to AB implies CD equals AB. Okay. And by transitivity, since XY is AB and AB equals CD, then XY equals CD. This looks like it makes sense. Zach says this looks like it makes sense. Yeah, I guess, right? If XY is equivalent to AB, but AB is also equivalent to CD, then by transitivity, XY is equivalent to CD. You just reverse the order here, right? An equivalence relationship needs to be reflexive. Okay, so A equivalent to A means that A equivalent to B implies B is equivalent to A, and transitive A is to B, B is to C, A is to C. Yeah. Okay, maybe by symmetry, okay. Yeah, maybe for here to say like by symmetry. Yeah. Some stuff Zach says. I'll post it in there for you as well. This is real analysis, right? Is that what we call this? Or I'd set theory for sure, I guess. But set theory, I think, is a part of real analysis. Oh, symmetric should be both ways. Okay. So here. So. We do it that way. Yeah. Okay, cool. I'm getting more comfortable with this.
That's dope.
But cool question. I always like getting exposed to things I'm not very comfortable with or haven't done before. And I really appreciate Zach and Jeff, you guys giving me some intuition on how this works. All right, nice. Okay, let's see. Who do we got next on the queue? Tuma, Fort Gonzox, and DM Scrader. Remember, you can always upvote. So Fort Gonzox, notice how like Tuma has more votes than you, because even though they submitted like not as long ago, they've been hitting the upvote button. So here, I'll do you a little favor and hit it for you. Okay. Let's choose a winner. Tuma's like, bruh, dude.
Bullshit. Not cool.
Let's go gambling!
It's alright, Tuma, because it's you anyways, dude. You win. Yes, you win. Ooh, the shell method. Is this the test you got a 60 on? Yeah, you can come up. What's up?
Okay, bro.
Okay, bro. Okay, bro. The shell method. Okay. Wait, alright, wait, what? To evaluate the definite integral represents the volume solid revolving by the plane region about the x-axis.
I just
Why are
forgot how to do it.
Why are they drawing shit, dude? What's all this? What's this garbage, dude? Why is there 1/6 in here?
They want you to split the integral.
Oh, okay, that makes sense.
Yeah.
Oh, okay. But we're revolving around the x-axis, right?
Yeah.
So we're revolving this way?
Yeah. In terms of y.
Okay. So, first thing, let's remember just to write down what the shell method equation is. So it's 2 pi a to b, and it's like, what is it? It's like r outer minus r inner, I think, right?
Yeah.
And then it's like d whatever. But since we're revolving around the x-axis, okay, so if we're revolving around this way, that means our shells are going to get built out this way. So we know right away this is going to be dy.
Wait, I don't think it's inner and outer though, because it's shell. It's just radius and height.
Yeah, actually you're right. Yeah. Let's do that. Yep. Radius. Well, it's technically, let me think.
It's like top minus bottom, right minus left.
Yeah. It's RH, and then this is going to be dy. Yeah.
Yeah.
Let me think. Yeah, actually, sorry, you don't have an outer and an inner because that gets encoded into this.
That's what confused me as well. But I literally wrote a paper for each case.
You wrote a paper for each case? What do you mean?
Yeah, like about the x-axis, about the y. Like, there's like,
Okay.
I got confused between like inner and outer, and like right minus left and top minus bottom. I don't know. It's like,
Well,
I
okay,
can't visualize it right.
Here's the difference. So this is being revolved around this, which is where the shape like touches. So there is no like hollow part, right? If, for instance, you were revolving around, let's say like y is equal to like -2, for instance, okay? Then how you get the hollow part is now r starts at r starts here,
Yeah.
and then it has to go out to here. But in order to code for that, let me think. Yes, in order to code for that, you would say, oh, your integral here, it would still be dy, but it would go from 0 to 1. But then when you're encoding for like what the r is, r would be equal to 2 plus y.
Oh, I see.
Because
Wait, 2 plus y because it's like top minus bottom.
not because it's top minus bottom, but because, right, r always says the distance from the axis of rotation, which if your axis of rotation is always at least 2 away from the x-axis, okay, then the point at which you're building your shell, right, has to be whatever
Like the
this
outer
y
point.
It's always the outer point, right? It's always the outer point.
Yeah.
Because even if it was like right here, let's say for instance it's building like this shell, that radius is equal to 2 to get to the x-axis plus whatever the y coordinate is to get to where you're building the shell.
Dude, oh my god, like why do I not think about these kinds of things? Like I'm just trying to like pack all the formulas in one spot.
Yeah, I mean, because you're memorizing things, but it's best when doing this to think of it intuitively in terms of like just distances, like, oh, radius is distance from axis of rotation to wherever I'm at. Yeah, don't just memorize shit. It's
No, yeah,
because
that's not.
you'll get fucked and stuff. Okay. But anyways, they were nice to us here. So they said this is the axis of rotation. Okay. So we know it's dy because my whatever things are getting bigger and bigger and they're going this way. And then in terms of y, right, that's going from 0 up to 1. So I can get rid of this and say this is 0 and this is 1. Okay? But now we got to think about, like, what radius is, right? So radius, again, always measures the distance from the axis of rotation. The axis of rotation is the x-axis. So any distance from it is just whatever the y-coordinate is. So we say r is equal to y.
Ah, I see.
Okay? R is
Yeah.
R is equal to distance from axis of rotation.
It's like the point from the outer radius to the.
Yeah, and this is why shells is weird, because we're not just taking this, for instance, right? We're taking this, like this counts, right? And then, you know, this counts. And whatever, like this counts. The only thing that changes is that the height of the thing I'm measuring is varying as I go up in y.
I see.
But I'm still traveling from here all the way to here. But as I do that, my height is then related to, like, to this function. In this case, the height is going to be related to whatever the x coordinate of the function is, and then it's going to be -1, because we don't count this. But we'll get to
So
that.
we're rotating about x, so it's in terms of y.
Yeah. So, yeah. For shells, if you have a horizontal axis of rotation, you use dy. It's opposite to washers.
Yeah.
With washers, horizontal axis of rotation would mean that we use dx.
Mhm.
But here it's, because it's shells, use the opposite ones, dy. So this should give you a hint already that I need my bounds to be in terms of y things, which in that case, y things are going from 0 to 1. Okay, so r is equal to y. Great. Now we need to talk about the height. This is where things get tricky.
Bruh.
Because the height depends which region you're in, okay? So when you're traveling from for instance y equals 0 up to y equals 1/6, the height of your cylinders are always equal to 5. Do you see how here this is equal to 5, but also here this is equal to 5, and also here this is equal to 5?
But where'd you get 5?
Okay, good. Because the shaded region, right, goes from 1 to 6.
Oh wait, it's because the little like rectangular thing, the yellow thing, that's
We don't-
literally the height.
That's literally the height. That's what they're trying to show you, yeah.
Oh.
Yeah. So when you're first, you're doing like two different shells. You're doing this shell, right? Which, again, you're still traveling this way in terms of dy, but your height is always 5 when you go from 0 to 1/6, okay? So here's where, like, if we look at the height, right? So the height is just always equal to 5 when y is in between 0 and 1/6. So you can say, like, when y is between, I don't know, you can say 0 less than or equal to y less than or equal to 1/6. Okay?
So boundaries can affect like the radius and the height.
Yes. Well, the radius should always be just y. The radius should be constant. Not constant, but it should always be the same equation. Because the radius is always pointing from like wherever I am here down to here. And that's always whatever my y coordinate is, right? Because that's the distance to the x-axis, which is also my axis of rotation. So this is for all regions. Okay. The height, however, right, is only equal to 5. Well, is always equal to 5 when y is between 0 and 1/6. But then let's look at what the height is when you're in this region, okay?
Right.
Oh, sorry. Okay. So when you're here, okay, now this is your height. See how that's your height?
Yeah.
Okay. And this is where you have to like do some.
Changes,
You got to put your thinking cap on. So as you're going up, right, this distance is changing. You see how it's this here, it's this here, it's this here. It gets like smaller and smaller, right? So we have to think, how do I represent that in terms of y? Because my integral is dy.
I think it was weird for me because like height is usually like up and
Yes.
not sideways.
I know everything's rotated cattywampus. It's 90 degrees here. Yeah. So okay, this is height, right? But what I know is this point, right? The point on this function, right? This has an x comma y, yeah?
Yeah.
The x coordinate of this function tells me this whole distance, okay? So watch. So from here to here, that's the x coordinate of the function. And what was the function again? 1 over x?
1 over x.
Okay. So you have to like rearrange this. So this, for instance, tells me that x is equal to 1 over y, all right? So this whole distance here is 1 over y. Does that make sense? Like going from here to here is 1 over y? Maybe. Like,
I'm just not visualizing it right.
all right, so if we look at like going along, the function is the black line, right?
Oh yeah.
So whenever I'm traveling at any specific y point, I can then reach out to this function.
Oh wait, it's 1 over y minus what's called 1, right?
Exactly. Yes. So
It makes it makes sense, yeah.
1 over y always points out to where this is, but I only want this distance, right? So the height in this case is equal to 1 over y minus 1.
Oh.
And that's for the region when y is between 1/6 and 1.
Okay.
Right? Because that funny business only happens once I've traveled enough up in y that I hit 1/6. Until that, right, when I'm going from 0 to 1/6, the height is always just 5.
So it's going to be
So you have to split the integral now.
2
You
pi.
have to split it,
Oh yeah, you're right.
right? Because I have my height is changing behavior based on what y I'm at.
But
So-
the radius is the same for both.
It is. So you can say 2 pi. So this would be integral from 0 to 1/6. The radius is always y. The height in this case is 5. And then that's just dy. Plus the integral from 1/6 to 1. Still a 2 pi out front, right? And then this is going to be, the radius is still y, but now it's 1 over y minus 1 dy.
Oh yeah, 1 over y minus 1.
Yeah.
Minus. Oh shoot.
Do you see that?
Dude, I got taken points off for not writing dy last time.
Surprise, motherfucker.
I mean, it is kind of important. Whenever I look at any of these volume of revolution things, the absolute first thing I do is determine whether this is dx or dy. Because
Yeah.
that it puts you in the right mindset to be like, okay, now every other variable I need to solve for needs to have y's in them. It can't have x's.
True.
Yeah.
But he also took points off for, freaking. Oh yeah, it's like skipping a step because like I already knew what the next step was. Like you know when you
Oh.
integrate something, I don't know.
Yeah.
It's silly. Like I already know the answer.
Yeah.
Wait, let me see the integral though. So it's y times 5, y times 1 minus. Oh, okay, I get it.
Yeah.
Damn,
So
it's
then
not.
this
It's
is.
not bad. Yeah.
It's not bad. I mean, this is a pretty tricky question. I will say. And then what is this? This is 2 pi. Y times 1 over y is just 1, right? So that's just y. Wait, right? Yeah. Y minus y squared over 2
Mm,
from 1/6 to 1. Yeah. And then this is the whole thing to do.
okay. Thank you.
But yeah, so this is tricky because you had to do 2 different areas. This is where doing washers I think would be a lot easier. Yeah.
Yeah, they forced us to do shells.
Yeah, because you would just go dx, and then r would just be equal to r would just be equal to fucking 1 over x. That's all it would be. Yeah, because then that accounts for this already. Because the y value of this accounts for like this distance as well. Yeah, this is so much easier with washers.
Wait,
I
how
don't know
would you do it using washers?
Oh, it's easy, dude. Okay, so if you're doing washers, it's a horizontal. Okay, so here, like washers.
But the radius is like the outside radius.
There is no
like,
outer radius. I mean, there is no inner radius. Sorry, it's just the radius because inner radius only occurs when you have a gap between your axis of rotation and the shaded area.
But what about the outer radius? Like, how's it?
So the outer
I'll
radius,
just-
right?
Yeah.
Yeah. So it's pi blah blah blah. What is it? It's gonna be r squared, and then because we're going this way, it's dx, and then in terms of x, we're going from 1 to 6, right? So then r, right? R always points from axis of rotation. Let me use a different color. Sorry. From even different color. There we go. Axis of rotation up to where the shape is, where the border of the shape is. And this distance is always just 1 over x. It's always just what the y value of the function is.
That's why it doesn't matter.
Yeah. So this
As long
just
as you have
becomes
the outer shape, right?
yes, as long as you have the outer shape, you're accounting for all the stuff
Under
before
it,
it,
the
yeah,
area.
under it. Yes, unless there's a gap. So if your axis of rotation was here, then you would have to say that r outer is 1 over x like plus this, and then like r inner is just equal to whatever this is, like, you know, minus 2 or 2.
If there was a hole, though, how would it make it harder?
Yeah, it just means there would be an r inner. So if this was your axis of rotation, and let's say this was at y is equal to -2, now r outer would be equal to 1 over x plus 2, because it would be this distance 1 over x, and then it would be also plus 2, and then r inner
Wait, it's -2, so it's 1 over
Yeah.
x minus -2, which is plus.
plus 2. Yeah. Don't with the negatives and the positives. Just think about what the distance is, right? If this is at
Yeah.
-2 and your x-axis is at 0, the distance is 2.
Oh.
And then r inner
yeah,
would
I
just be
never
equal to
thought of
2. Yeah, don't worry about the negatives. Just think about like physically, like how far does it take to go there.
Okay.
But yeah, and this would just be easy because then this is just pi 1 to 6 1 over x squared dx, and then you're done. You don't have to like break it up and do all this like gross stuff, dude.
Surprise, motherfucker, huh?
Doing too much.
Yeah, I don't know. It's just terrible. But okay, cool.
Absolutely.
Makes sense.
Yes, sir.
Nice.
That's dope.
I would leave the stage now.
When's your makeup test?
It's tomorrow.
Oh, okay.
Disqualified.
All right. Well, hopefully, this was an actual question that was on your exam.
No.
Oh, okay. This one's a
But,
toughie.
Yeah, I figured I'd try to, because I'm actually like not struggling right now. It's just I just wanted to understand this one because it was like tripping me up.
Yeah.
Yeah, like the rest of the questions, like I'm actually doing pretty well.
Oh, good.
And yeah, so
Yeah,
I understand what I was doing now.
Yeah, don't make dumb mistakes. You'll be fine.
Yeah.
Okay, cool. All right, nice. All right, let's see. Drew says, I don't understand a thing on this board, but I think it looks cool.
Oh, yeah.
I think it looks cool too, Drew. All good. You'll get to this eventually. Let's see. What else we got on... all right. Let's spin the wheel again.
Let's go gambling.
Fort Gonzog!
Good job.
Thank you for waiting 85 minutes. Oh, wow.
That's a crazy time to wait.
That is a crazy amount of time. But if he had hit upvote more times, like during it, he would have got picked earlier, like you did.
I just put an interval, like a 3-minute interval.
Oh, and you have it auto clicking?
No, it's just like I just click it by myself, but every time it like rings, I just click it.
Wow, look at that dedication. That's super cool, dude.
I'm trying to
You
pass,
can get-
bro.
You can get plugins, you know, they're Google Chrome plugins that you can just like have it just like click, click, click.
No way, I didn't actually know that.
Yeah.
But in like the background, what if I'm using that monitor?
Oh yeah, no. Or maybe, I don't know. I'll have to see. There's probably some new stuff these days. All right. Bowling ball is rolled down a frictionless lane and hits a stationary pin head on. The bowling ball continues moving in the same direction after the collision. Consider the system to be the bowling ball and the pin negligible. Linear momentum in the X direction only. Well, I think they want like graphs maybe? Okay. All right. So I guess there is momentum from the ball because the ball's moving at the start, right? So yes. Should be like none from the pin. You just like draw a graph. So momentum, right, is mass times velocity. So the bowling ball hits the pin, it has to slow down somewhat. So because P is equal to mv, you have to have like slightly less momentum happening. But the total momentum needs to be the same, right? So that means the momentum in the pin in the X direction would have to increase. And the key thing here is that this should be the same. J external. I don't think there is any J external. Yeah, J is impulse, right? Yeah, J external is equal to delta P, delta T, which is also equal to MA, which I think is equal to a force. Yeah. But there's no external forces. Yes. Change in momentum. Yeah.
This is like when you have potential and kinetic energy, and they like they're like changing. Yeah.
Yeah. It's so like energy isn't always conserved, but momentum is in collisions.
So like the total would stay the same.
Yes, exactly. Yeah. Is an elastic collision because there's no heat? This is an elastic collision because there's no heat of collision? It's probably, well, in order for it to be elastic, the kinetic energy before and after would have to be exactly the same. So yes, there'd have to be no heat and also no deformation. So for instance, the pin can't deform. Yeah. Okay. Now consider the same situation, but for the pin system only. Wait, what? Okay. Well, for the pin system, what? Well, the pin doesn't see the ball then, right? I'm confused. Wait, what? So in that case, this is 0. So I guess it doesn't see the ball. But then it does get smacked, right? gets smacked by the pin. So there is definitely an external J that happens. So this would be like force from ball on pin. And now this would have to have more momentum. The difference between the two charts, I would be like, you don't consider the momentum of the ball in the second chart. Yeah. Cool. Nice.
Well done! Well done!
This was Gonzox. Okay. Yeah, it's more conceptual. I mean, it's not terrible. I mean, you should know like how momentum is changing and stuff. All right, let's spin the next one.
Let's go!
Oh,
Let's go gambling!
Deems Greater. Oh wow, there's a lot going on here, dog.
You should make the board interactive.
How would the board be interactive? What would
Like
you
we
want?
we can draw on it too.
Oh, yeah, that would turn into chaos though, dude.
Disqualified!
Like only the person you're helping gets access.
Oh, yes, I have done that in the past before. And it is totally possible. Like I did it during the podcast on Saturday. I gave access to Ramton. Yes, I guess with people I trust, like you, it would be okay. If I gave it to everyone, people would just like start drawing dicks. That's the problem. Like I know what people will do. Yeah. Yeah.
I don't blame you.
Or like swastikas or something. I'm just like, please don't get me banned, guys.
Gonna get banned on Twitch.
It's why whenever we play like Jackbox games, I can't ever stream those games because yeah, I'm just like no. This is like
I don't know what that is.
it's a fun little trivia game, but like people can write whatever and it comes up on the screen. And
Oh.
I'm just like, yeah, I know where this goes. I know instantly what type of jokes this goes to, and it basically just becomes like the locker room group chat. Jackbox games are fun. Yes, we have done them. While we're uploading questions, which username do we use, TikTok or Discord? Use your Discord one, because that's how I track whether I give you points and stuff. Oh, I forgot to give you points too. No, one second. I fucked up on that. Or no, I did give you points. I didn't give points to Gonzox. Well, because I don't know who Gonzox's thing is. Okay, whatever. All right, here we go. Use card B to answer the following. There are 18 data points in scatter plot B. Wait, do I have to like fucking count this, dude? Really? You want me to count how many dots there are? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes. There are 18. That is true. Agree? I don't know. I use my eyes. Okay. The longer students take on a retake quiz, the lower the score. I mean, that is true. There's a downwards trend here. And R is negative, and pretty close to -1. So I would say, I would agree. And I would say because R is negative, that means there's a negative correlation. Not necessarily causation. And you could say R squared is close to 1. Which means there's a good correlation. Yeah, negative slope. Negative slope works too. But seeing whether R is positive or negative. Here it goes. Scatter plot G could represent a linear model. Yeah, I agree. This looks pretty linear. Yeah, sure. Yes. Explain? Well, R equals 1. If R equals 1, that means it's a very good correlation.
My man.
At 8 degrees, there was approximately 130,000 phytoplankton. At 8 degrees... Well, there was approximately 25,000. Not... What did it say? 30,000? I would say no. I would say like 25,000. Okay. The correlation coefficient of 0.76 means this has a positive, weak linear association. Yeah. Is that weak? I guess it is, right? Because 0.7 squared is 0.49. I would say, like, yes. Yeah, the graph also doesn't even go that high, Drew. You're right. Yeah. And you can say, like, r squared is like, basically 0.5, which means 50% of variation is explained. And that's weak. That's definitely weak. That's weak, bro. Dropping here for good news, Jade Gamer says, I got 98% on my math exam. Nice. Overall, 92 for the module. Best result since I was 16.
That's dope.
Congrats, Jade Gamer. Good job, bro. Yeah. Very good, dude. Celebrate. What are you gonna do to celebrate? Go get some ice cream or something, yeah? That's what my mom always
Better
said.
than my 60, bro.
Disqualified.
Yeah, your poor teacher. Your teacher was kind of like going hard mode on you guys, though, I guess.
She made me graph every question.
That sucks. I mean, you honestly should, though.
I know, but it's like doing too much.
As temperature increases, ice cream sales decrease. That is false, because it is a positive correlation. Say false. Say no. And it's because R is positive. So, it should be a positive relation. I think they call it a positive relationship, right? They call it positive. Yeah. Oh, wow. Oh, that's intense. It was based on Calc 3 stuff? Good job, Jade Gamer. Linear algebra, wow. And the Fourier stuff? That can get scary sometimes. Congrats, dude. Are those like, is that your further maths exam? Or is that like O levels? Or A levels? I think it's probably A levels if you're doing Calc 3. Anyways, good job, DM. Oh, you're a second-year university student. That would make sense. So these are like above your A levels. You're in university. Oh wow. Even better, dude. Nice. What are you trying to major in? I just got a 59% on my Calc 2. Reki. You're smarter than that. I know you are, Reki. Yeah, what happened, dog? Yeah, that's big oof. All right, we got 8 minutes left. And then I gotta go to a pretty important meeting about my job. All right, so let's see. Let's spin. Who's gonna win?
Let's go gambling.
It's Tuma again. Wow.
Yes.
You have a 90% chance. Gamer Drew next. Yeah, don't worry. Let me see. I can probably get through this one quickly and then... Or maybe I can't.
I don't think it's...
Alright, maybe it's not that bad.
Yeah.
Okay. The figure is the side of a tank filled with water. The dimensions are given. Find the fluid force on this side of the tank. There's the density. Okay. And it's y is equal to x squared. Okay. So if y is equal to x squared... Alright, so y equals x squared. Let's just solve... I know I'm going to need x. I know I'm going to need that. So x is equal to the square root of y. So the width is equal to 2x, which is equal to 2 square root of y. Okay. Alright, so fluid force equation... This one's not as bad as the other one, at least. The other one was like 2 triangles upside down, and it was offset, right?
Oh, yeah.
Yeah, that like super sucked, dude.
I just used the form. It never even appeared on my exam. First time.
Okay. Where was it again? Which formula was it? Is it this one? Yeah, it's density HYLY, I think. Yeah.
Oh right, yeah.
Yeah. Yeah. Okay. Look, I think it's density times G. Yeah, it's density times G HW. Okay. Okay. So force is equal to density times G, and then it's HW, and then D something. Okay. Or it's usually dy is what it is, because we care about. Yeah. Okay. So we're gonna go from, because H, this is depth, okay? So this is a depth of 0, and this right here is a depth of 16. Okay? So I know right away this is going to equal to rho g, this is going to be 0 to 16. H
What's
is now
GG?
going to be, that's just density. Density. I think this is the 6th. I think rho g is, this is 62.4.
Oh,
It's usually density times gravity. So this is 62.4. This is like pounds per meter cubed, which is also equal to, it's usually like 997 times
sure it's
9.8
cubic feet, right?
kilograms per meter cubed. Oh yeah, sorry, feet cubed. Yeah. Yeah. That's a conversion where this is rho, this is g, but this together is rho g. It's a
Yeah.
physics thing.
Oh, I see. Okay.
Okay. So then we gotta think about the width. How does the width change? Okay. So the width, right, is equal to 2 square root of y, but y is measured from here. Does that make sense? Like, if I did it where, like, this was y equals 0.
So the width is 2 square root y.
Well, yeah, I gotta change things. I gotta change it. Okay. Here.
And the
No, we're
other
gonna
one
change
is just
We're gonna have
negative
this.
y,
We're gonna have this go from 0 to 16, but now I'm gonna call this equal to 0. It's wonky.
right? Oh, I see.
Yeah. Okay. So this is still gonna be y, but now the width is gonna be 2 square root of y, and then this is dy.
Oh, that's why the 2 square root y didn't work?
Yeah. Well, originally I had it going from. I think this works, right? Yeah, I think this works.
Probably. It looks right to me.
I always forget like how the it's because you know what you know where this fucks up. Okay, look. When y is 0, right? That means the width
Yeah.
is 0. That makes sense. Like here, the width is 0, but I need the depth to not be 0. I need the depth to be 16. So this ends up
Oh, I
being
see.
16 minus y. So this is the height, or this is like the depth,
16 minus y.
right? Because
Oh, wait.
okay, because when y is equal to 0, right? I need the depth to be 16. So 16 minus y gets me just 16.
I think I understand what you're saying.
And then when I go up here to y equals 16, right? I need the depth to be 0. That's why this becomes 16 minus 16, which is 0.
16 minus. Oh, is it not 16 minus
16 minus 16, which is 0.
Oh, I see. So 16 minus y.
Yeah. Wait one sec. Yeah. Why aren't we integrating over dx? No, there's no dx here. Okay, cool.
2 square
Yeah.
y dy.
So yeah, I think it's just 62.4 integral from 0 to 16. 16 minus y, 2 square root of y dy. That's what it is.
You're kind of doing it backwards. It's like the other way around. That's what
Yeah.
confused me.
Yeah, well, okay, because
Is it harder to do it the other way around?
yeah, the other way around would be it's 62.4, and now you're gonna integrate from 0 to 16. This becomes y, but now my width is not 2 square root of y, because this is like a different y. Because in this equation, y equals x squared, you're assuming that this is y equals 0. So in this case, it would be 2 square root of 16 minus y.
But with the limits reversed?
No, the limits are still the same. You're still going from a depth of 0 to a depth of 16. But then the width is equal to 2 times the square root of 16 minus the depth. So when the depth, for instance, is 0, my width is the full width. It's 2 square root of 16. It's 8. But then when when my depth goes down to 16, right, now it's the 2 square root of 0, and that makes sense because the width down here should be 0.
I see.
So
Is there
this
not
is
a
like
version where it goes from negative 16 to 0?
negative 16 is 0. No,
Right?
no, you don't. Yeah,
No?
don't. Yeah, no, because then this needs to be negative. Here, this is like top to bottom, and then this is like bottom to top.
Would the width be harder to find?
Well, here you see the width is this, right, and then this is bottom to top.
Like in the other case where it's like negative 16 to 0?
Yeah, you'd have to like flip some negative signs in places.
Oh, I see.
Yeah.
Okay, I guess
I think
this is fine.
it's best to like define your coordinate system in the same coordinate system that the graph is, and then you got to
Yeah.
think about like what depth is. So
Okay,
when you're up at like y equals, for instance, 4, the depth needs to be equal to 8.
Right.
So depth is equal to 16 minus y. So whatever your y coordinate is as you're going up, the depth is equal to 16 minus that.
I see.
Yeah.
Just screenshot this.
I'll save it for you. You're good.
Oh, okay.
Yeah.
Probably clear.
Let me download this.
You have like really good like quality on the stream, even though you're streaming through Twitch.
Oh yeah, no, I stream on I stream on like 3 different platforms. The Discord is whatever. I think I run that at 720.
Oh no.
But yeah, the Twitch is great. That's 1080. I used to have it running at 1440, but then I just don't have the bandwidth for it. It's too much.
What's your graphics card?
Oh no, it's not a graphics card issue. It's literally a bandwidth. It's internet. That's all it is.
Oh, I see.
Yeah. All right, let's choose winner. Let's see what we get. Next one.
Let's go gambling!
Bro, if it's not
Is it gonna be Rascals? No, it's Gamer Jam. All right, Gamer Jam.
That would have been really bad.
All right, Gamer Jam. What do you want me to do with this? Let's go, bro. Yeah, good job. What do you want to do? You want me to factor it or what? You don't have to do factors of 3. I don't think there's factors though. Okay. Yeah. Usually I would try to like split this by pairs. But 12 and 5 and 4 and 2, they're not good ratios. If this was, for instance, like 12 and 4, and this was 6 and 2, this would maybe be possible. Because 6 to 2 is 3, 12 to 4 is 3. I posted it for you 2 minutes here. You know where it is. I just tagged you. There you go. We could try to do rational root theorem, right? So it's the roots of 2 over the roots of 12? Is that what it is? Oh, there's nothing like the quadratic for powers of 3? I don't think so. I don't think there's like a cubic formula. You can like try to guess factors. So I think it's the factors of this one. Oh, fuck, where did it go? Sorry. So factors of the divided by the factors of these. So it's like plus or minus 1, plus or minus 2, over plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Yeah, it's ugly.
Bruh.
I don't think you can group, though. No, I don't think grouping works. Just because of ratios. These are like possible roots. Cardano's, yeah. I don't know. I'm just gonna graph it. Could you split the minus 5x and minus 4x and minus x? Yeah, but then you have 5 terms is the issue. I don't think this turns into anything like nice. 12. When in doubt, graph it out. Let's just see. I just want to see if anything nice shows up. Okay. Looks like maybe a half. Yeah, where's that bouncing at? Oh, that's interesting. What do we think this is? I think it's negative a half. Yeah, factored form, but I cheated. Yeah. Okay. Yeah, this is kind of the... again, you can graph to get intuition. These are all the possible roots. So it's all the possible factors of 2, which is plus or minus 1, plus or minus 2, divided by all the possible factors of this. So these are all the different combinations that can happen. And if you pick the lucky one, the right one. So in this case, if you pick, what is it? 1/2. You'll see what you get. So let's say by intuition. So by luck, I pick x equals 1/2. Then that's 12 times 1/2 cubed, plus 4 times 1/2 squared, minus 5 times 1/2, minus 2. So this becomes 12 over 8, plus 4 over 16. Oh, sorry, plus 4 over 4, sorry. Minus 5/2, minus 2. So what is that? Divided by 4. So 3/2 plus 1, minus 5/2, minus 2. Yeah, it needs to be negative 1/2, actually. Yeah, I take that back. Yeah. Let's guess negative 1/2. Yeah, sorry. Positive 1/2 actually wasn't going to work. Okay. Now I get 12 times negative 1 over 8 plus 4 over 4 plus 5/2 minus 2. Okay. So this becomes negative 3/2 plus 1 plus 5/2 minus 2. Minus 2 is the same thing as minus 4/2. And then 1 is the same thing as 2/2. So watch this. So now you get 7/2 and then minus 7/2 equals 0. Okay. So that tells me x equals negative 1/2 is a root. So 12x cubed plus 4x squared minus 5x minus 2 can be written as x plus 1/2, it's x minus the root, times something else. So now you would need to do synthetic division of this by x plus 1/2 to find out what the rest of the thing was. Yes, and then you can divide by it. Yeah, okay, cool. All right. I do really have to go, but that's how you would do this one. There's no like easy form for it, and then you get solutions. But cool. Okay. All right. All right, nice. Let's close the stream.
That's dope.
All right, thank you everyone for coming to Actual Education Office Hours today. I appreciate all the questions you guys had. Super fun. Let's see. That was Gamer Jams. One sec. Let me make sure I have everyone's questions in. Drew Gamer Jam. There you go. Cool. Ooh, Pro Noob. I did want to do yours. Yours looks good. Yeah, the magnitudes of this, like the batteries and stuff. Yeah, fuck. If I had more time, I would do this. But this is going to be in our Discord, Pro Noob. So, and I'll mark it as like unsolved. So either one of our other awesome friends will solve it at some point, or the whatever the bot will go after it. Yeah, okay, cool. All right. So, yeah. That's the last stream until at least probably March 20th-ish, March 21st. So, I have to go to Japan tomorrow. You guys have fun and all that stuff. I really appreciate everyone on the stream. You guys are great. Make sure go check out our website. Again, actualofficehours.com. You can click on the streaming schedule, and that's all the awesome other people that are streaming while I'm gone. So make sure go check out Zach. Let's give Zach a shout out. Zach's great. Go check out Penn Center, and I will make a guest appearance for Pi Day on Zach's stream from Japan on Saturday. Yes, thank you. Okay, cool. All right, let's go raid someone. Who are we gonna go raid? Let's see, who's on Monday? Monday's kind of a weird time. Oh, Obi is. Okay, cool. Go say hi to Obi. Obi's great. Looks like O is doing Math Mondays fun stuff. Nice. All right. Enjoy the rest of your week. We will see you in about 2 weeks. Peace.
See you.